Well, we're starting a new unit today. This unit's only, I think, is through the next 2 weeks, maybe 3 weeks. It's going to be a pretty long one. Well, we're going to learn about electronics and then we're going to start building circuits.
Writing about it?
Learn. Man, you'll have an activity. Don't worry. You gotta write some notes, draw some little pictures, build some circuits.
I had to build a robot.
They say learn, not write.
Well, you can learn by writing, reading, and experiencing. I mean, it's all relative. What's that? We can make a robot if you want. Name the gentleman. You can name the gentleman if you want. Robot Stanford. Or your finding robot.
We are real steel. Are we making a sewer?
But it probably won't be that advanced.
Who's cherry? Who's cherry?
All right.
Yeah.
So, I'm going to trust you guys. Let's see, I have 11 batteries. You're going to make light. 2, 4, 6, 8, 10. Are there 11? 6? Perfect. Everyone gets a battery. Here, pass it on.
I only trust Duracell, man. I'm not Duracell. I have a silver one. I want a silver one. I want a silver bullet.
There you go.
What's your plan? No Oh.
Some more.
Oh, I think I did. I get two batteries, I get some then wire get it from both, so it's like both. They connected and they turn it like
Did everyone get a battery? Who has been you need battery? And you need battery. Come over with me. Hey, why don't you jump back to that table? That'll give me tails. Yes, sir. I'll take those.
What's your name?
Ludwig, Ludwig. Ludwig.
Ludwig?
Lud.
That's your name? Your first name?
My first name is David. You can make me up when it comes over.
I'll call you Joe. We'll call you Joe.
Well, actually, I have to take that back. You have to call me Mr. Joe.
Mr. Joe.
Okay, so your task is this. Hey, you, right here, you need to go back to that table. Alright, then you have to come up here. You guys have to come back. Alright. Yeah, I'll just leave you two alone. Here's the task. Light the light bulb. Ready? Go. Oh, it's on.
I lit the light bulb.
Other question. it is, we got two.
Very good job.
Hey, what's up? Keith.
Dude, you see this one? Right.
Gets hot? Did you get the bolt to light? Ask for some help. Hey, you guys need help?
Oh,
They need help. Yeah, it's gonna get hot. Make sure you have a light bulb there.
You don't want to do it.
The answer there, how to sweep this? You go. All right. That's all you should know about.
You get it? Alright, who still needs some help? You guys back here? JR? No, JR and Keith and
who needs help?
nice work. You girls get it?
Oh, I knew that. Yeah.
You get it, Keaton? Awesome. All right. I'm going to ask you to do something really difficult. I'm going to ask you to put this stuff down and push it forward and don't touch it yet. Just set it aside for a couple seconds. We're going to chat on the board. And then we'll go back to the circuits. Don't you worry. And we'll get some more stuff in there. But try and not touch it. Oh, don't do it. Okay, so we have a battery. What else do we have?
Wire.
We have a wire.
Heat.
What else do we have? And a light bulb. Let's see. Something like that. We'll call that a why not? Light bulb, right? Okay, so how do I hook these up?
Do those two cords.
All right, so I've got my battery. Where do I put my light bulb?
On top.
On top, right here.
Yep.
Only connect one light.
Okay, I've got one wire I can't get here.
Then stick the other wire out, then grab the other wire, along the wire, connect it to the bottom.
Right there?
Yeah.
Okay, we'll fill that in. Good job. So some of us had our, let's see, circuits like that. Now, why doesn't this light up? It's not getting energy from the other side.
It's not positive.
Great observation. Okay, so you're saying like one side is negative, one side's positive?
Yeah.
Yeah, the opposite of my circuit too. Hey, look on the battery. See which side's got.
Yeah, the top.
Top is positive, this negative. Okay, so it's not getting energy from here. Good observation. Let's see. That's it? It's a wrap?
Yeah.
Turn it on.
Try another one?
Try a different bulb.
We're going to talk about three things, three requirements for a circuit. We have three requirements for a circuit. First, we need a voltage. What is voltage?
Power.
It's the power, and it comes in the form of a battery. Good job. So voltage. Don't worry about notes right now. We'll get to notes later. Voltage. Okay. We need second thing. We need a load. A load.
The load of energy is just the wire?
The wire? No, it's not the wire.
The wire carries the load, right?
Carries the load. Not quite. What's the load? Jared. It's not the wire and it's not the battery. So it's the It's the light bulb. So we need a load. And then the third thing we need is some kind of connector. We need a complete connection.
Wire, we need the reload.
And that's where the wire comes in. And occasionally we'll have a switch because you want to turn your thing off. You have a switch on your flashlight so it doesn't look dead. So you don't have to take the batteries out all the time. You have these 4 things. Okay, who can tell me one of the 4 things?
Light bulb?
Light bulb. What is it?
It's the load.
Okay, you can't say another one. JR? What else? Voltage. And what is the voltage? Power, but it comes in the form of a battery. Okay, and there's one more. Those were the 3, and then there's a 4th. So you can turn it on. A switch. Okay. So I drew these pictures, but there's like a real way to communicate it, and it's called a schematic. And so there's symbols for each thing. For example, a light bulb looks like this. That's what a light bulb looks like. What's a schematic? It's kind of like a map. They call it the map or like the building plans. You know how you see blueprints for a construction job?
Yeah. Diagram.
It's a diagram, thank you. So it's a map, diagram, instructions, frames. This is a light bulb. This is a battery, and the battery looks like this. A bunch of lines, a couple ends, positive on one side, because it's polarity sensitive. It has different poles. Okay, and then finally, wire looks like that. Okay, who can tell me what this is?
Light bulb.
Battery. Wire. Okay, let me check my notes real quick.
Cheap wire.
Let me throw a couple more at you. And like I said, don't take notes. We'll do this tomorrow, actually. This is just kind of a sit back and absorb as much as you can. This right here is a switch. And we call this a single pole, single throw. So the pole is this. There's only one of them. It's confusing because there's 2, but really on this side there's only one. And the throw is this guy. So what would we call that? So we have how many poles on this side? 1. And then how many can we throw to?
2.
So we call this a single pole double throw. Good job. So there's some other things we need to learn. This is a resistor, which just means that it resists. It's part of the load. We'll get into that later. Don't blow your mind on it. This is a buzzer.
That's a taser.
And then we have a plus and a minus. That's what a buzzer looks like. It just makes noise, you know? Or like an alarm. This is a fuse. Who can tell me what a fuse is? When you blow a fuse in your car. It's kind of connected. Fuse, oh, that's like something you light and it lights off a firework in a bar. That's the fuse you're thinking of? So there's, a fuse is just like a protector. You put it between 2 wires in case it gets too hot or the electricity goes too fast or it comes too much, it just cuts off and so your circuit dies. And it's cheaper to replace this part that blows up or goes bad than to replace the whole circuit or start a fire. So it's kind of like a safety. Yes, sir?
We haven't had a fuse go on the car, right? Headlights. You had to change the place on, replace a fuse on your car? Okay, or your blinker fuse or something like that?
Yeah.
Okay. That's the same type of thing.
So when we draw a schematic, we draw wires like this, and we're going to have this thing right here. Do you remember what that is?
Battery.
Who said it, Touch?
Yeah.
All right, good job. And then we have this thing here. What's that? And then we're going to throw in this thing here. said no? Coach, you've been speaking a lot. We're going to go back to, do you think this will light? If I connect a circuit like this, battery, light bulb, switch, wire, do you think it's going to light? Probably will light. That's a very good guess. And why do you think it will light? Sorry, I can't hear you. They're all attached. Very good observation. So the switch, and I haven't taught you this yet, the switch can either be this or that. And what is the difference? Touch.
The switch, when it's turned on, like, is that top when it's on? Like,
Okay.
it connects to anything, like, the lit flows through, electricity.
Yeah, and this one?
And that one is, like, stopped.
It's open.
Yeah.
Okay, so when the switch is open, electricity can't fall through. Keenan, did you catch that one? This one right here, Keenan, this switch, is it open or closed? Closed. All right, don't help him on this one. Open or closed? Okay, now we're going to go back to our circuit. Is this open or closed? Wait, Keenan. Is this switch open or closed?
Closed.
It's,
Yeah.
is it closed? Remember, this is what closed looks like. And this is what open looks like. So what is this one right here?
Open.
Good job, it's open. All right, JR. So, will this bulb light? Why? Church, will that light?
Yeah, probably.
Okay, so we need three things. What are they? This is for church. Battery, which is a voltage,
And then load,
which is a light bulb.
and then, connector.
A complete connection. A complete connection from positive to negative. Good job. Okay, and this one goes to Fifi.
You sleeping?
All right, Fifi. Does it light? Do they light? Doesn't light? Why? You don't know? All right, who's gonna help Fifi? D'Angelo. That's right. D'Angelo, will this light? Will this bulb light? If the thing was closed? If it's like that, will it light?
Yeah.
Okay, good job. Now, my question is, are these lights going to be brighter? Are they going to be dimmer? Or are they going to be the same? They're going to be dimmer? You say dimmer. Okay, you're not allowed to talk anymore. JR, you're off too. Right here. Brighter, dimmer, the same. Going to be the same. Alright, Sharp? Sharp, what do you think? Brighter, dimmer, the same? Dimmer. Alright, does anyone think that it's going to be brighter? More bright? Does anyone think it's going to be more bright? Okay, so we think it's just going to be the same, or it's going to get more dim. Well, we're going to build it. JR. Look. Light bulbs. That's a little light bulb. You, sir. Give one another wire. So everyone needs 2 wires total, so let's give them just 1 wire. Go. All right, go ahead and build it. Once you have it built, I'll come around and check it out. tape on wires.
Oh, I think that was it.
No, it's just here, take that. Okay. Okay, class, if you're bending your wire a whole lot, like back and forth, it's going to snap off, and then it will look like this. You probably can't see it very well, but it no longer has wires sticking out. So in that case, you just take off more of the plastic so that the wires exposed. But just be kind of careful as you're manipulating that you don't snap it off.
You got it.
Yep.
Got it.
Does it look like this? No. Battery, light bulb on one side, light bulb on the other side. Well, there's no switch.
Yeah, light on this side, light on this side. Okay, this was. Put it on this one. Teeny bit. You broke it?
If you need my help, call my name, I'll come help you. Yes, ma'am. Yes. So if you want to like take the wires together, and then you want to connect the wires, so they can be. Or if you want a wireless stick to here. So you don't have to- Yeah, yeah. You're fucking with it.
Work?
Yep, just like that. Got it?
Cool. It's pretty bright too. The brightest one I've seen so far, I think. They use that better battery. warm on your fingers yet?
You got it?
Right, that is. Yeah. You need a different type of circuit.
Just a gym and diet. What? See how they look.
You did series two.
And you did series 2. All right. I need to grab your guys' attention for a second. They call this just-in-time learning because it's like just in time, you know? Perfect timing. So a lot of you guys are doing something a little bit different, which is good, but good for next week and not today. So you guys are
Listen
doing
up,
this-
guys.
You hear me? You guys are setting up in parallel. There are 2 types of circuits. We won't get into the hairy details. One is series where it's all in one big loop, and then the other is parallel where there are a whole bunch of small loops. So you see how this is one big loop. Some of you guys are doing it like this, where a light bulb is here and a light bulb is here. Do you see the difference? Coming out of the battery, you have 2 wires. And each light bulb is on its own loop. However, what I want you to make right now, hey, why don't you pull out your batteries so you don't kill all the light bulbs? What I want you to do is to make it one continuous loop, where the battery, the light bulb, and the wire are all in the same loop. So there's just one wire coming off of one side of the battery, and one wire coming off the other side of the battery. Got it. So for those of you that discovered this, that's very good. But we're going to take a back step, and we're going to learn this first before we get to that. Here's some stickers. Did you get yours? I did some power slide.
That's all right. He can fix that. Is that why?
You guys did.
There we go. Okay. All right. It's pretty dim. I didn't see it the first time.
Oh, no, you do it. It's hard. You didn't get it? Hey, Dad, son. You did? Yeah. You didn't get it? No, son. All right, I'm going to get your attention up here again. So remember, put the stuff in front of you so it's not distracting. This is the hardest part of the class, not touching the battery. You're not supposed to. Go ahead and push everything in front of you at the top of your desk. Yeah, see, it's tough, I know. I know it's tough. You want to reach out and grab it. And keep playing with it. I need you to teach about flow and electricity real quick. I need my black marker. So I want you to imagine a tube that's filled with ping pong balls. It doesn't just have one ping pong ball in it. It has a ping pong ball like every inch. So it's packed completely full with ping pong balls. Now if I put a ping pong ball in one side, what do you think is going to happen to the other side? Let me draw this. Okay, if I put one ping pong ball in there, what's going to happen? One's going to come out. And if I put two in? Good job. So electricity is like that. Electricity flows. So there are all these electrons in the wire. And when you put this charge to it, this like voltage, this battery, it starts moving those electrons. And this guy moves this guy, and this guy moves this guy. It's this chain reaction. And so if I want to send electricity for 200 miles away, like Glen Canyon sends to California, well, it's like, I don't know how many miles, 500, 700. These electrons are moving each other all the way along there. So there's some loss, right? How much time do we have?
Yeah, about 10 minutes.
10 minutes?
16 minutes.
16 minutes. Okay, so that's how it flows through a wire. Now we're going to learn about voltage. And it helps me when I draw pictures. And so I'm going to draw you guys the pictures and we'll make an analogy. We'll call this an analogy. So we have Lake Powell here, right? And at Lake Powell there's a big old dam. And people ride on boats. Anyone out go skiing or fish tubing or fishing. Go swimming, it's real warm. Okay, so there's all this water here. All of this water. Now let's say we take a hose and we put it at the bottom. Hey Linnell, if I've got this hose at the bottom right here and I open up the valve, what do you think is going to happen? The water is going to come out. Now, let's say the water level is only here, not here. Do you think the water is going to come out faster or slower? It's going to come out faster? It's going to come out slower, and it depends on the hose. You're telling me if I have a big hose, it's going to come out faster. What if I have a small hose? Slow. All right. So we're going to say voltage is this push. The voltage is the push that pushes all of these ping pong balls. And in this case, water. Voltage is that push. It's pushing. Okay? So if I have a higher voltage or a higher push, is it going to come out faster or slower? It's going to come out faster. Okay, so that's voltage. Voltage is the push. What's the voltage? The push. And it comes in the form of a? This little metal thing that we connected our light bulb to. It comes in the form of a battery. Where else does voltage come from? How else can I get electricity? Car engine. Good job. It turns an alternator, which creates electricity. Where else do I get electricity? Moving things. Okay, I can create a generator. In this room, where do I get electricity from?
Power tower.
From an outlet. Good. So we have all this wiring coming to an outlet. Those are all forms of ways, all ways we can get electricity. So there's another unit, and this one is going to be called flow. Well, the unit's called current, but it's going to be the flow. So if I take a snapshot of this right here, I'm going to ask myself, how many ping pong balls are moving across per second? Right? How fast is it coming through? Not how many ping pong balls, like in total, but how many per second. Does that make sense? So if I push it, let's see. Let's do it this way. And if I'm not explaining something very well, you just raise your hand and say, hey, I don't get it. Let me try it again. Okay, so if I take this snapshot right here, if I can see into this window of the pipe, and I see 5 ping pong balls go by in a second. How many ping pong balls go by in a second? 5 per what? 5 per second. Great. So current is how fast this stuff is coming out. What's the push?
Voltage.
Voltage is the push. And what's the current? Good, good. Let me create some buzzwords for you. Current is equal to flow. Voltage is equal to push. Current is flow. How fast is it going? Voltage is push. How hard is it going? Doesn't make a lot of sense, does it? Okay, I'm going to draw one more picture and then we'll die. And then we'll be done. Okay, so some of you discovered this on your own. If you have a battery, if you have a battery in a single wire and it's connected from here to here, it's going to get hot, right? And it's going to burn your fingers.
On the top part.
On the top part. When you pinch, it's going to get real hot. This wire gets super, super hot. Does anyone know why the wire gets hot? Oh, because of the flow. Because it's going so stinking fast around and around and around. And when you rub your hands together, or when you have a pen trick, whatever you kids do these days, it gets really, really hot, right? Friction. So this creates this flow that goes super duper fast, and it gets hot. That's flow. Now, what if we put a light bulb in here? What happens? Lights the light bulb. What happens to the flow? Does it slow down or speed up? Slows down because it has to go through here. And it makes this light work and then finally comes back out. It goes quite a bit slower. Now, what happens if I put a second light bulb here? Ah, tricky. Oh, see, I'm tricking you on this one. So if I put one light bulb, or if I put one ping pong ball in, does just one move, or do all of them move? All of them move. So if I have a ping pong ball here, and here, and here, and here, are they going the same speed or different speed?
Same speed.
Same speed. Good job. So if I have another light bulb here, is it going to get slower or faster? It's going to be the same. Oh, interesting. So this right here is the same as this? It has to be, right? Because if you push one this way, it's got to be pushing that way. Okay, what's that called? Flow. So current, flows, and voltage? Push. Okay, who has an example of voltage for push? Water. Explain that. So if your water level is higher, do you have more voltage or less? Because there's more pressure, there's more push. If you have less pressure or less water height, what does that mean? Okay. So imagine this is the pipe that comes out of the dam. It's just blowing up. And this water is flowing through here. Linnell. The water is flowing through here. And so you have all this water up here, and it's being held back by a dam. And then we have this small hose about this big that comes out. Now this water is going to go pretty fast, right? Now my question to you is, what if we put a stop here? It's going to be going the same speed. Okay? It might be going the same speed, but the amount of water that's passing through, is it going to be less or more? Less. What if I bring it all the way down to here? It's going to be less or more? Less. When I eat a whole bunch of hamburgers and my arteries get plugged, does less blood go through or more? Less. Less blood goes through. This we're going to call a resistor. It's resisting flow. It's resisting the push. Let's see. Controls the flow. Good job. Okay, so here's the application. Are you ready for it? I've got a wire, and then I've got a light bulb. And then I've got a wire and a light bulb. What is the resistance? The light bulb is the resistance. Good job, Tish. So I'm going to come through here, and the wire and the light bulb resist the flow. It kind of slows it down. This is the load. It loads down the circuit, slows it down. It resists. And then I come through here, and what does it do? Slows down the circuit. So if I want to speed it up, what do I do? Okay. And if I really want to speed it up, what do I do? And then what happens? Super fast. There's nothing to slow it down. Only the small resistance of this wire. There's some resistance. You can hardly measure it. But that's the only thing slowing it down. And so those electrons are going super, super fast. And what happens to the wire? It gets hot. And then if you don't catch it in time, what happens? It what? If it's in your house, what happens? Sparks. And then fire. Char, that's it. Char, and then what happens if your wire gets too hot? In your house? Hey, you're not Char. Go ahead, Char.
I have an example of this. Show me one.
What happens? So in the wall you have this insulation, and you have wood, and some paper. And if you have a wire that gets super, super, super hot, what's going to happen eventually? Well, it's going to start a fire, exactly. And so this is called a short. If you just have a wire and no load on it, it's called a short. And the wire is going to go fast, or the electricity is going to go super fast through the wire, and you're going to start a fire. Those are called shorts, and they're really, really bad. Let's see. Checking for understanding. What is a voltage? Wait, no, Jared, I'm sorry, I can't ask you anymore. What is a voltage? It's the push. Good job. And what's the flow, VP? No. Current. Good job, Tosh. Let's see. There are three things that we have to have for a complete circuit. D'Angelo, what's one of them? You have to have a wire. He says wire, what he really means is a complete circuit. What else do you need for a, what else do you need for a circuit? You need a battery. Good job. All right, see you tomorrow.
Good job, man.
All right, good.